The Weibull function. The Weibull function returns the Weibull distribution. We use this in reliability analysis, such as calculating a device mean time to failure. The syntax is Weibull of x, comma alpha, comma beta, comma cumulative. The value at which to x is the value at which to evaluate the function, and here the alpha is the shape of the parameters, and beta is the scale. So the syntax is x, alpha is the shape, and beta is the scale. We'll use the example of Google Sheets in the Weibull function. So starting with this example. Here we have a Weibull reliability analysis. We have a sample index and the times of failure of a device. So you copy this and paste it here. The next step will be to sort and re-rank it. So we have sorted the times of failure and change it to rank. So first we sort this, rearrange it from lowest to highest, that is ascending. So array formula, sort of this range. Now that it is sorted, we rank it, re-rank it, which is using this sample index scale. So array formula of the sample index. Now that we have re-rank and sorted it, we can now calculate the Bernard's median rank formula, which is equal to rank minus 0.3 all over maximum rank plus 0.4. So array formula, rank, no, that's not array formula. So array formula, rank minus 0.3 all over maximum of the rank plus 0.4. Enter. So starting from 0.0673 up to 0.9326. This starts from 0.673 up to 0.9326. So these values, the Bernard's median rank matches to our calculations. Now we can calculate for the values of y and x, starting with y, which is the logarithm of 1 over 1 minus median rank, which is this. So the values of y will be array formula ln 1 over 1 minus the median rank. So our value starts from negative 2.66 up to 0.9926, and it starts negative 2.66 up to 0.9926. So our calculations are correct. Next, we calculate for the y values. That's the ln of the sorted times to failure, which happens to be this column. So this is our array formula, ln sorted times to failure. So the answers start from 10.57 up to 11.347. Let's see. That's 10.57 up to 11.347. So our calculations are correct. What's next? We go downwards. Now we're using Linest. We're not gonna use the full statistics. We're only interested in the slope and intercept to calculate for the alpha and beta. So here's what I'll do. Linest data y and data x. This is the slope and this is the intercept. Our slope is alpha. So alpha equals beta. 4.88497, and our alpha is 4.88497. Next, we calculate for the beta, which is exponent of b0, or the intercept, over the slope. So it is the exponent of intercept divided by the slope. So equals exponent negative intercept divided by the slope. And our beta is 67,119. 67,119. So we got values of alpha and beta. Now we can calculate for the survival probability. That's the next step. We calculate for the survival probability. And here you have the times starting from 1,000 to 10,000. 1,000 to 10,000. And the survival probability. You have this Weibull of this value, A43, alpha and beta. So we will not use this. We'll instead use array formula. So this is array formula. Weibull of the times, comma, the alpha, the value of alpha, comma, the value of beta, comma, 1. So survival probability starts from 0.00000913. So 0.00000913. That's correct. Until 0.999099. Its value. It is 0.999099. So our calculations are correct. Now we can calculate for the reliability. We'll use the formula used in the example of Google Sheets. So 1 minus, I'm not going to use this. This is too messy for me. So we'll use array formula. This is equal to array formula 1 minus the Weibull functions. So our answer will start from 0.9999, 0.9999 until 0.000908. 0.000908. So our answers are correct, match to the answers here. This, then we can chart this. Insert chart, and we'll use the scatter chart. We'll use the scatter chart and show the trend line. Polynomial, use polynomial to the 10th degree because we'll try to maximize it. And we use the equation. Show the equation, put it on the left or put it on the right, whichever is convenient. We'll put it on the right. Expand this. So here we have the trend line and the trend line equation of the Weibull function showing the survival probability in blue and the reliability in red. So this is the reliability in red, survival probability in blue. This completes the use of array formula, Linus polynomial, sort and maximum and ln functions to generate the dataset of the Weibull